This is a problem constructing comparative box plots. Thought we'd talk about a really controversial topic, crunchy versus creamy peanut butter. I think we all know which one is better. We'll see in a minute when we look at the box plots, see which one was better, voted better. I thought the 0 to 100 was kind of broad range to score peanut butter. I don't know how they did that. I would be very stressed voting on that scale. Maybe they had like some kind of criteria. I don't know. But anyways, type all the numbers into a data set, into a spreadsheet. So I already did that. Pause it if you need to. And we want to get the 5-number summary for both sets. So we need the 5-number summary for crunchy, the 5-number summary for creamy, and then we're going to make comparative box plots. So pause it and do that. Okay, so what you do is you make one number line, but you also need to clearly label which plot is which. Which plot is which. I like to make mine going horizontal. Some computers like to do it vertically. Just whatever your preference is, go with it. I learned horizontal, so I make my comparative box plots horizontally. So the 5-number summary for crunchy is 5, 55, 62. That Y is in the wrong place. Well, it's blocking. So what was that? 62, 67, and 82. 5-number summary for creamy was 34, 40, 46, 5, 52, and 90. So make one long number line. And these are scores. Now, for some crazy reason, someone scored crunchy at a 5. That person must have been crazy, because that's the better of the two, right? I don't know why, but it kind of makes our score, our number line, have to start way low. So given that it's so low, and then for some reason someone scored the lesser of the two peanut butters so high, we have to number from at least 5 to 90. I'm going to go by tens and go 0 to 100. So there's 0. Let's see if I can do this in one shot. I don't know, that's not very to scale. We'll see how it looks. And by the way, if you missed the box plot lesson, those 5 numbers, the 5-number summary, I'm referring to min, Q1, the median, Q3, and the max. Notice I scribbled out outliers. That takes a ton of time off of working this problem. We can go pretty quick. We'll practice with outliers later. Right now I just wanted to give you a visual of comparative box plots. So let's start with creamy. I'm going to make a line at 40. Make a line at 52. So these are my 2 quartiles. Make a box. Make a line at 46.5. And draw a line down to 34. And a line up to 90. So there's creamy. Crunchy, let's draw a line at 55. A line at 67. Make a box. A line at 62. Draw a line all the way down to 5. I don't know why they did that. They were crazy. It was a biased response, or a bad jar of peanut butter or something, like random. And then a line up to 82. And there we go. We have two box plots compared. Note, it is very difficult to see, if not at all, shape. Very difficult to see shape in box plots. But you can definitely see center. You can compare the medians. You can see spread. You can compare the ranges. IQR is another measure of spread. Look at these IQRs. They are very similar. The width of the box is very similar. Ranges are very different. Medians, the centers are very different. Maybe an unusual value out here. I don't know. I bet it's an outlier. So those are the things you could talk about. Notice we have a percentile right there and right here. This, let's change colors. The red line is the 25th percentile of crunchy. The purple line is the 75th percentile for creamy. I could talk about that. I could say that more than 75% of crunchy scores were higher than the were higher than the bottom 75% of creamy. Or I could just say than 75% of creamy. That's a big deal that those percentiles are past each other. That's comparative talk you could do. All right, hopefully that was helpful. See you in class.